Hello class. Okay, so according to the survey, cosmology and relativity kind of tied. So what I'm going to do is combine them. It's actually pretty easy because cosmology, modern day cosmology and everything that we know kind of comes from our understanding and the discovery of relativity. So they're very intertwined. Relativity, you can look at relativity in terms of anything, from person to yourself, to time, to planets, to cars, anything. But it was actually relativity. Einstein wrote his equations and his theory of relativity based off of what we knew about cosmology. So relativity is kind of born from cosmology. So we're going to look at relativity in terms of cosmology. Okay? So what cosmology is, basically, it's just the study of the origins, the history of the universe. So we'll kind of just go through certain topics, little by little each day. Like I said, this will be more of a quantitative type look, so it won't be a whole lot of math involved. A lot of it's just going to be personal research, and you doing personal research and submitting papers. Not big papers. I'll have some like terms that you'll need to look up and just kind of define them in your own words so I know that you understand them. Okay, so we're going to start off with obviously the Big Bang, because that's where the universe started from. So we don't really know much about what happened before the Big Bang. We do know a little bit, but it's very theoretical. So we're going to start with the Big Bang. Okay, and we're going to go through this pretty slowly starting off. Just so you can start getting used to some concepts and terms. Okay, so basically, back in Einstein's time, if you remember from Einstein, the series that we watched, back then they believed, as far as in terms of cosmology, they believed the universe, or all the stars in the universe, were just kind of there. That they weren't moving, it was just very static. Okay? And they just believed the universe was static. There was no beginning, there was no end. It just was. This is how it was. It was like glued. They said, like, if you put flies on fly paper and you basically expanded it, that's basically what it was. The planets were just kind of glued into place. But Einstein had an issue with this. They did know about the four fundamental forces, which holds true still to today. That is the strong and weak force, and then the electromagnetic force, and then gravity. The strong and weak force only act on the particle level, so only within atoms, so very, very short distances. And Einstein knew that there's only two forces that can act across the universe, and that is gravity and electromagnetism. Stars, they're not charges. They don't carry a charge. This one's not a positive charge star, and this one's not a negative charge star, so they can't attract. So, electronegativity didn't apply to stars, but gravity did. And that was the only force that Einstein could think of that would apply across the entire universe. However, the issue is, what do you think of when you think of gravity? Yeah. So, if we have gravity, things tend to want to go towards one another. Okay, so gravity would be pulling stuff in. If this star was the biggest within this area, stars will go to that one. And if this one is even bigger, then so it's just like any other. The moon orbits the Earth. But because observation says that, or at least at that time, that the universe was static and the stars were not moving, Einstein knew that there had to be something stopping all the stars from clumping together. Okay, and so Einstein called this so wherever there was gravity, which basically was everywhere, there was always something pushing against gravity. Okay, Einstein called that the universal constant. Okay, he didn't know what it was. He didn't know what could be causing that, but he knew it had to be there in order to balance out gravity, in order if the universe actually was kept in place. Okay, so when he wrote his equations, he put in just a constant. I think it actually was mu. I'm not for sure what the original one was, but he just put in a constant into his equation to balance out gravity. Okay, just like we do when we don't know what the constant is, we just put a C or a K or something. That's basically what he did. He just didn't know what it was. Well, it wasn't until a person by the name of Edwin Hubble came along, and this was basically where the idea for the Big Bang came from. Edwin Hubble didn't discover the idea of the Big Bang. He just kind of gave the very first evidence that led scientists to actually find the big idea of the Big Bang. So Edwin Hubble came along, and he realized that when he looked at stars, he actually was looking at stars to see their chemical composition, so what they were made of. So if you've ever heard from maybe chemistry, the electromagnetic spectrum, okay, he was just basically looking at stars through the electromagnetic spectrum to see what they were made of. So for example, hydrogen, which we know is the most basic element there is. It's the first element on the periodic table. It's the first element that there was in the universe. Hydrogen has a very distinctive spectrum when you look at it in the lab. When you look at it in the lab, you get like a white, a yellow, a green, and a blue, and you get one each. Okay? And so he knew that if he looked at stars, and if they were made of hydrogen, he should see that same spectrum. However, there was a little difference. He saw two different things. He saw the hydrogen spectrum, the white, the yellow, the green, and the blue. However, they were slightly shifted. They weren't exactly where they should be. Or they were shifted the other way. Okay, so this was hydrogen that we see in the lab, and he saw the same spectrum, but it was all these were either offset to the left or they were offset to the right, one or the other. And the only thing that he could think of was to explain that was what's called the Doppler effect. You may know an example of Doppler effect from like middle school of like an ambulance. When an ambulance is coming towards you, it sounds higher, and then as the ambulance goes away, the tone of the siren gets a little bit lower. That's because the wavelengths gets compressed as they head towards you, and they get stretched out as they leave you. It's kind of a similar thing he was seeing here in terms of the wavelengths of the electromagnetic spectrum. Okay, so some stars was red shifted, and some stars were blue shifted. Okay, but they all did show hydrogen. And so those red shift and blue shifts meant, just like the ambulance, that the source of those waves, the stars, had to be moving. And that was against what common scientific knowledge people at the day believed the universe was. They believed it was static. And Einstein, he had an issue with that. He just didn't know where some evidence could come from. And then Hubble, looking for chemical composition of stars, actually saw that they were red and blue shifted. Okay, so that's pretty much all we're going to get into today. That was quite a bit actually, even though it seems like it was kind of brief. So here's your assignment for today. So we're going to take these three big topics we talked about, and basically I just want you to summarize in one paragraph, a high school paragraph, so 5 to 6 sentences. Summarize Einstein's universal constant, summarize the electromagnetic spectrum, and the Doppler effect of stars. Okay, so the electromagnetic spectrum, in terms of cosmology, the Doppler effect, I don't want you to talk about ambulances, obviously we're talking about cosmology, so the Doppler effect in terms of stars, and then Einstein's universal constant, what it was, why did he come up with it, stuff like that, okay? So just one paragraph for each. All right, thanks guys, have a good day.